We investigate the question as to whether StyleGAN can benefit face recognition. Face recognition typically requires an enormous amount of images with identity labels. Such datasets are usually comprised of celebrities and feature a limited number of distinct people. At the same time, virtually infinite amounts of faces without labels can be gathered from social media. A number of works find a way to create artificial identities from this data by augmentation-based procedures. Instead, our idea relies on learning a generative prior on the unlabeled data for subsequent face recognition training. This paradigm follows the self-supervised learning approach, which requires a pretext task to be solved to learn the prior. In our approach, we make use of the StyleGAN generator and pre-train it together with the inverse network. The backbone, pre-trained to recover latent codes from an image, is later fine-tuned for the face recognition task. In particular, the first pre-training stage involves training StyleGAN-2 on a specially collected prior dataset of unlabeled images. During the second stage of pre-training, a convolutional encoder for StyleGAN is trained on the same unlabeled prior dataset. Coupled with StyleGAN, both define an asymmetric autoencoder with a frozen decoder. Finally, the encoder is fine-tuned for the downstream task on a standard face recognition dataset of labeled images. This step follows the recently introduced PSP approach. In order to scrape a million-scale collection of unlabeled data, we propose the following simple procedure. First, the set of YouTube channels typically featuring different people in their videos is specified. All available videos from the specified channels are downloaded, cut into separate frames, and all available faces are extracted and aligned. The simplicity of our procedure allows us to investigate biases of face recognition, which is an important research topic. To this end, we have collected nearly 5 million African and more than 3 million East Asian faces by only selecting YouTube channels with predominantly these demographics. We demonstrate the effectiveness of our pre-training technique on a standard RFW dataset. The highest quality increase is observed when all available prior data is used. Accordingly, the baseline with our enhancement performs on par with other fairness-concerned state-of-the-art methods. Our dataset features 6 times larger number of people than RFW and is free of potential selection bias. Since RB-WebFace is a more challenging benchmark, the same comparison of the baseline versus our approach shows the quality difference in a more expressive fashion. This implies that the proposed pre-training benefits other state-of-the-art pipelines, such as SphereFace and GAC, and hence can be used as an ad hoc improvement of an arbitrary algorithm. The design choice of StyleGAN for pre-training is confirmed by comparing it to standard autoencoders. The improvement can be attributed to the higher fidelity of StyleGAN generations and its better scalability. The procedure is especially helpful for tailored face recognition applications when obtaining a lot of labeled data is problematic. The plots on the slide demonstrate the accuracy improvement for 1%, 10%, and 100% labeled data used. Accordingly, we show that the performance increases with the size of the prior dataset. Finally, we motivate the use of a generative prior instead of synthetic samples with an ablation, where the training set is augmented with interpolated images. We show that doubling the dataset size with them does not help as much as the proposed generative prior. Our answer to the initial question is yes. The StyleGAN coupled with an encoder network provides an efficient prior for a face recognition network. Thank you for watching.